Donagh, and I'm the director of the VistaMilk SFI Research Centre and a geneticist at Teagasc. And I'm going to talk to you today about breeding for more profitable and socially responsible animals. I'm going to start off with trying to explain to you what a ruminant is, and then I'm going to conclude with how we can breed for these more efficient animals. So just to start off with, what is a ruminant? Ruminants are cattle and sheep, and the unique thing about ruminants is that unlike us, they contain around 4 stomachs. And what's inside one of those stomachs, called a rumen, is a lot of bugs and bacteria, and what it enables the cow to do, or the sheep to do, is break down forages like grasses and clovers, which we ourselves as humans cannot break down. And those bugs, they transmit or they convert that grass or clover or other forages into an energy source for the individual animal or the ruminant. But however, what these bugs do in the meantime, as they do that, is they release this thing called carbon. And that carbon bonds together with hydrogen to produce methane. And that's what a lot of people talk about. So why are these ruminants really important? Well, around 40% of the global terrestrial land mass is actually grassland. And the vast majority of that is inadequate to actually produce crops. So there's very little that we can do with it. And as humans, of course, we can't eat this grass. So what we're doing is we're relying on these ruminants to convert a source of produce, grass or clover or another forage that we ourselves can't eat, but convert that into an edible source of energy and protein that we ourselves as humans can eat. But as I said, the problem associated with all of this is that it produces what we call greenhouse gases. And one of these greenhouse gases is methane. So what is a greenhouse gas? Well, a greenhouse gas, if you look at this graph here, it just shows the radiation from the sun coming through the ozone layer and bouncing back up into the atmosphere. But the circle around the Earth, this is the greenhouse effect, just like you have yourself at home in a garden, and this stops all the radiation from going back up and radiates it back down to the Earth. And that's what keeps the actually warm. However, too much of this greenhouse gases, too much of this glasshouse effect causes an increase in the temperature of the Earth. And of course, this in itself leads to erratic weather conditions and climate, such as greater rainfall, higher temperatures, etc. And what I'm showing you here on the table is just some of the greenhouse gases. A lot of people talk about methane, but we have all the other ones. Another common one people talk about is nitrous oxide. The unique thing, in a way, about methane is that, on average, it only lasts in the environment for around 12 years, compared to other greenhouse gases, like nitrous oxide, for example, can stay in the environment for around 10 years longer. So what the experts in these greenhouse gas effects have done is they've produced a statistic called the global warming potential. And over a 20-year period, this methane has a global warming potential of around 84 to 86 units. So it's the equivalent of the warming potential of 84 to 86 times that of carbon, while the other greenhouse gases are way, way worse. Next slide. So like any business, what you want to do is you want to look at your cost benefit, you want to look at new products, the benefit of introducing those new products into the system, or for example, if you have a new technology. What is the cost of the new technology and what will it deliver to you? And agriculture is absolutely no different. But what we call these kind of cost benefit analysis is, when it comes to environment, is the marginal abatement cost curve, or the MACC, M-A-C-C. And I'm just showing you, and I'm going to take a few minutes just to describe very clearly what the MACC curve actually does. It's produced by Gary Lanigan and colleagues at Teagasc. So what you can see is, you can see bars, the length of the bars are a reflection of what we call the abatement potential. So how much of the carbon can these individual technologies reduce by? The vertical axis then is the cost benefit. And you can kind of see a horizontal line there at 0. So anything above that represents a cost to the system. Anything below the line represents that this is actually a profitable benefit to the individual producers. The width of the bar, or the abatement potential, then tells you how much. So what I'm going to show you now, I'm going to highlight 2 of these particular areas. One in beef, called the Beef Genomics Scheme, and one in dairy, called the EBI. That's just an index, and I'll talk about this in a second. This is just an index that dairy farmers or dairy producers use to identify the best bulls and best cows for them. So what I want to highlight here is the width of these bars are really large. So breeding, beef or in dairy, has a massive potential to reduce the carbon footprint of agriculture. Also, importantly, they're under the line. So we can see other technologies above the line that are good and wide, like fertilizer type, but they're a cost to the system. You have to buy these products. While in breeding, to produce milk or to produce a calf, you must put the cow in calf. So you might as well put it in calf to a good, environmentally friendly and socially responsible bull as put it in calf to a bad bull. So it's under the line. And the main benefit, as I said earlier, is that with breeding, it's cumulative and permanent. If you look at some of the other technologies like fertilizer type, you have to keep applying those year on year. And that's a new incurring cost every single year. While in breeding, you build on it year by year. So if we just focus now on the EBI, the Economic Breeding Index, next slide. So again, like any business, you have to have a goal. I'm going to go through the goals of each of the three different species. And let's just start with the dairy goal, the Economic Breeding Index, the EBI. As the name suggests, it's economic based. So it's in Europe. This is showing how it has evolved over time. The blue here is the emphasis on milk production. And many people might think that dairy farmers are predominantly just interested in milk production. And that is true, but that's not all that they're interested in. They're also interested in the longevity or the well-being of the animal. So in red, what we have there is longevity. And at the end of the day, longevity or survival is probably a great manifestation of the well-being of an animal. Animals that have poor welfare status, they tend to die. Animals that have long or good welfare status, they tend to live for longer. So back in the year 2000, so almost 20 years ago, we started selecting for animals that were happier and that lived longer and had better fertility. And over that time, we have included more and more traits. These traits become more and more these traits are more important. So, for example, the beef merit of the animal, the calving difficulty. So calving can be a really stressful time for cows, like it can for any female, the birthing process. So we want to minimize the difficulty that's going to happen to the cow during that particular time period. And we've been selecting this for the past 15 years or so. Next one is health, obviously crucially important from a welfare perspective. Mastitis and lameness are two of the biggest diseases that influence dairy cows across the world. So we have been breeding for animals that, yes, have higher milk production, but they live longer and have superior health and fertility. And then finally, one of more late is maintenance. On average, and I'll come back to this one, on average, bigger cows eat more and thus, on average, produce more methane. So we've actually been selecting or putting a negative selection pressure on cow size to increase the production without necessarily making the cows any bigger, who in turn eat more, which in turn, on average, produce more methane. So that's the dairy breeding goal. Next slide. Here just shows you our two national breeding goals for beef. I'm not going to go through them in any great detail, but the point I want to make on this and on the next slide is that farmers or producers and breeders alike do not select solely for one trait. There might be a perception out there that farmers want fast-growing animals in beef and in sheep, and that's true, we do, but we don't want it to the detriment of the welfare of the cow or the animal itself. And you can also see here, we don't want it to the detriment of the welfare and safety of the farmer himself or herself. So we have animal docility inside it. So now I want to show you the sheep breeding goal. Very, very similar to the cattle breeding goal. You can see a whole range of different traits inside here. And what we're proposing, if our research is successful, is that the next time I show you one of these slides is with something like methane emissions would be inside it. So we'd be selecting for reduced methane emissions. Next slide. However, we're not starting from a zero base. We have been improving the efficiency, environmental efficiency and feed efficiency and economic efficiency of our herds and flocks over the past few decades. Remember the previous slide I showed you about the EBI of dairy animals? So remember, the EBI was profit-based. The higher the EBI, the more profit the animals leave behind them. And I'm showing you here by the year of when the animals first calve. So this is just really an indication of genetic progress. In the blue, I'm showing you the EBI of the national Irish herd. So it's improving year on year, which means that our animals are becoming more and more profitable. So again, when we talk about sustainability, many people would think about environmental sustainability. It's crucial that we're always also thinking about rural sustainability, and rural sustainability means more profit. So these animals are more profitable. We can see from the two components, the milk and the fertility, they're more profitable because they're producing more milk, but they're also living longer. Now, when we do the actual maths on this, what we realize is that over that time period I'm showing you here on the graph, the amount of carbon produced per kilogram of output, so that's what milk solids per cow, has reduced by 14%. So not even working directly on methane, we are improving the efficiency of our herd. But what I'm going to pose this question for the second half of my talk is, can we actually go any faster by directly measuring methane emissions? And I'm just using methane emissions as an example of environmental traits. There are others like nitrogen use efficiency, etc. Next slide. So you may remember earlier on I said that bigger cows on average eat more, which on average produce more methane. The key there is the word on average. And this is just simulation data, just to make the point. What I'm showing you here is the amount of methane produced on the vertical axis, and across the horizontal axis is performance. So if it was dairy, it would be milk yield. If it was beef or it was sheep, it would be growth rate. Cows, on average, that milk more, produce more methane. Beef cattle that grow faster, on average, produce more methane per day. Sheep that grow faster, on average, eat more, so therefore, on average, produce more methane per day. But what I'm showing in the red dotted lines is if you actually look at the vertical line here for the same growth rate or milk yield, you can see a massive difference in the methane production per day. Now, what we don't know really at the moment, there is a little bit of international data, but in Ireland, we feed our cows out and our sheep outdoors a lot on grazed grass, while everybody else, most of the other countries internationally feed them indoors. So it's not really practical to take the results from other countries and apply them to an Irish situation. So what we don't know is what is that variability. So here I'm showing it's varying from around 250, maybe just under 600. Is it that big or is it a lot less? And then, and only then, can we decide it's worth chasing. Next slide. And why I say is it worth chasing is to measure methane is really, really expensive. It's also really difficult. So for example, in milk recording in dairy cows, we would milk record maybe around 700,000 cows annually. So a sample of milk is taken from those cows around 4 times during the year to measure the milk yield and some of the milk composition. We simply can't do that for methane based on the current state of the art. Because one of the technologies that is used is what I have here in front of me. It's called the green feed system. I don't want to go through it in any great detail, but what happens is that concentrates, which are the equivalent of kind of sweets for cows, they come down in through a hood. The cows or the cattle go into that individual hood. You can see one of them in the diagram going in there. They eat those concentrates, and as they're doing it, like we do ourselves when we're eating our dinner, they breathe in and they breathe out. So they're breathing out the methane. And all the gimmicks that you can see behind that hood, they're measuring the methane. Now the cows or the cattle are allowed visited a few times per day, and you need them to visit a few times per day. But over that time period, over enough days, you can actually measure the methane produced by those individual animals. The trouble is that this is expensive. And this is that was a graph. This is just showing you some of the equipment that we actually have in Ireland, right? So on the left-hand side there, you can see the two of them in Katie Starsmore operating. These are the only two machines in Ireland that measure methane at grass. These are on our Dairy Research Institute in Moorpark and Teagasc. So you can see the cows come into those hoods and they eat the concentrates. X allows us to measure the methane. The one in the middle, that's an indoor system. Again, very similar system. Indoors, the beef animal, you can see them inside there eating it. And on the right-hand side is a sheep. It's like he's in a bit of a washing machine, but that just holds the system pretty airtight, allowing in oxygen, but not allowing any of this methane to actually be released, and allows us to accurately quantify the methane. The sheep are not in there for very, very long, so there's no welfare issues there. The problem, and I'm almost finished now, but the problem with all of this, I said earlier, is that we need data. If you want to breed for something, there's three things that the trait has to conform to. One, it has to be important. Now, I doubt there's anybody out there that won't tell me that environment is not important. So we tick that box. Environment is important, so therefore it's worthwhile, definitely worthwhile, researching it, and if successful, breeding for improved environment. The next one is there genetic variation? So if every single cow in the country produces exactly the same methane, which then you can't make any improvements. Now, very little data at the moment, but it is quite clear that there is significant genetic variability amongst animals, which means we have some animals genetically produce more methane, and similar animals fed exactly the same diet who genetically produce less methane. So we want to select, all else being equal, we want to select the animals who produce less methane, as long as they also perform well, and that's key. And then the third point, of course, is the data availability. I told you we have around 700,000 cows milk recorded. We're measuring considerable number of animals, beef animals and sheep for their live weights. We're getting a good idea of performance. We just can't deploy these type of technologies on such a large number. So what we're trying to do is to look for alternative low-cost technologies. And I'm just giving you one example here for dairying. So a lot of what happens within us, in our stomachs, whatever, materializes in what we excrete. And you go to the doctor yourself and you might have some sort of an ailment. One of the things the doctor will do will take a urine test. So they're using what comes out of you as a reflection of what's happening inside in you. And it's not that dissimilar in cows. So I told you about the methane is produced in the rumen, which is one of the stomachs of the cows. A lot of what happens there comes out via the milk. And in dairying, we milk the cow twice per day. Also, I told you earlier that nationally, around 700,000 cows get a milk sample taken around 4 times per year. And what happens with all those milk samples, you can see it here in this little machine in the middle, is light is shone on the milk in the infrared region, in the mid-infrared just to be region if you want to be clear about it. And that is used to measure the fat, protein, and lactose of the milk currently for all cows across the world. Our hypothesis is that we could also to predict the methane production. And this is active research as part of a SFI CERT project. The advantage, remember, again, it comes back to the whole data availability issue, is that then we don't need to deploy these really expensive technologies across all these animals across Ireland. We essentially could capture it through the milk. So my take-home messages is sustainability is key, but it's crucial when we're talking about social sustainability that we're also talking about profitable sectors, dairy, beef and sheep, for rural sustainability. I believe, and I think the evidence is quite clear, that there is unbelievable opportunity here in all livestock breeding and feeding to improve the environmental efficiency of our animals. Again, I focused a lot just on methane, but there's a whole plethora of environmental traits that we can look at. The main advantage, and this is not to discredit any other strategies, the main advantage of breeding is that to produce an animal, the dam or the female must be bred. It is cumulative and permanent over time. And unlike what a lot of people would say, it's not actually slow. It is very, very fast. So I believe there's a massive potential in breeding for more profitable and socially responsible animals. Thank you.